Let's turn Venus into Earth. This is all about terraforming. Who forgot about Mars? Terra means Earth, so terraforming means Earth forming. In this episode, we will have some boards about how to terraform. An example, Mars. We'll have a story where a fictional space agency turns Mars into Earth. We'll have a 10 under 10. We'll have some resources. So, how do you think we would terraform an example, which in this case is Mars? So, for Mars, first we need to make the magnetosphere and atmosphere. So, we stop the solar wind from taking away Mars's atmosphere by building a magnetosphere. I'm going to explain more about that later. But basically, the magnetosphere takes the particles of the solar wind which take away the atmosphere and make a shield for those. And we also have to make the atmosphere a lot thicker by releasing frozen carbon dioxide and frozen water. And we can use an equation which also makes it warmer. Added bonus. Need to make water. So we will use the soil to make water, which is iron oxide, because of this equation. This is iron, this is water. Yeah. But Mars has toxic soil. So we might use the property of diffusion, put something with less poison in it on Mars, so the poison gets sucked out into that and then keep repeating that process. Or we could use chemical reactions like this one. We also have to turn up the gravity by squishing Mars or just making it more massive, because gravitational force is equal to the gravitational constant G times the first mass of the system times the second mass times the mass of the second object in the system. All of that divided by the radius of the system squared. So if we put the mass of one of these two objects up, F will go up. If we put the radius down, squishing Mars, F will go up. Who forgot to grow plants? Who? Was that you? Anyway, we can grow plants by putting the minerals in the soil up, because there are minerals but all the way at the bottom, and putting water into the soil so that the plants can grow. But we might have to use greenhouses as well to make it even warmer for the plants. By the way, terraforming is a long process, but #AwesomeQuantum has just finished scratching the surface. Playtime in the sandpit. This time, instead of Lego for play, I'm using the Scratch software. Let me explain a little bit. So, Scratch is a way to make whatever type of code you want, whenever you want. And it's block-based. You can code anything, anywhere, anytime. There are different types of blocks, and they're all in different colors. So here there is like where you see the animation. Here is like a little bar, and then here is where you see the code. Here is where you can take the blocks, all in a very nice format. So now let's see the animation. So there is Mars here. So now we're making a magnetic field with like magnetosphere by cutting into it, making the core iron and starting the core spinning. Arise! There. So now, using the equation for the water, we are gonna pour some water on Mars. Water to Mars! Come on. Yes. Water. And now, using our poison equation and drawing it up, we will get the poison into the jar. Arise! So now, we're gonna squish Mars to just get more gravity on the surface. Remember our equation. And now Mars is small. So now we will put mirrors in orbit to make it warm. See, that is a lot of mirrors. We are planting plants. Mars is turning green. We are planting plants. It's time for 10-10 under 10-10. I hope you remember what it is because I'm not explaining it. 10 under 10. 1. The first organisms. I didn't say humans. I said organisms. Anything alive. Was seeds, not plants. Seeds at 134 kilometers. That's pretty high up. In 1946. That's a long, long time ago. 2. Lots, and I mean a lot of plants have been in space. I think that there's been like plants in space since like 19 something something. 3. Plants grow faster in zero gravity than in Earth gravity because there's no gravity pulling them down. 4. We can actually see traces of dry, of course, rivers and lakes on Mars. How awesome is that? The gravity of Mars is 38%. That's not much. Of the gravity of Earth. That's less than half. Dust storms frequently, like once every 2 Earth months, cover the whole planet. That's not so frequently, but it's frequently for that. The warmest Mars ever was 20 whole degrees Celsius. Are you getting this? That's Mars. This is Earth. This is Mars. That's the sun far over there. This far away. The escape velocity on Mars, like if you throw a rock up, how fast it needs to go to escape the gravity, is like a lot less than on Earth. We would need spacesuits on Mars. Otherwise, guess what? Our bodily fluids, like your spit and your blood, would boil from the low pressure. There's actually a field called astrochemistry. Doesn't that have the best name ever? Let's see what our magic resource cabinet has cooked up for us today. I know it's something good. Space Encyclopedia, the best book ever. Even though each topic only gets a few pages to itself, it'll leave you an expert on every single topic with stunning illustrations. This is the best book ever for you space fans. Planet Earth and the Universe, presented in a more packed format, but it still is a very good book with all sorts of boxes and colors and diagrams. It tells you about everything from deltas and estuaries to caves, to rivers. What's the next one? Here! The Inside and Out Guide to Spacecraft! Woohoo! Featuring brilliant illustrations of all types of spacecraft that you can think of. This book is truly a really good book. I'm not gonna spoil it. You read it yourself. Okay? When you finished watching this video, what you have to do for me is like, subscribe, and hit the notifications bell to get all the new videos. There are more links in the description below. And here is a joke to leave you on a happy note. Living on Earth might be expensive, but at least you get a free trip around the sun every year. Remember, you are never too young to